Hello, my name is Alex Powell, and this is my presentation on the project titled Study of Machine Learning Models for the Purpose of Natural Language Classification. In this presentation, I aim to outline my motivations for this project and give an overview of what techniques and tools I use to complete my objectives. This includes my conclusions drawn from the data collected and a personal reflection on the project as a whole. I decided to create my project based around AI and natural language due to its wide-reaching effects on our world. This extends to both research and business fields, as both areas have seen large amounts of growth within the last 10 years. This, combined with my interest with AI, which started in a module in year 2 of university, made this topic an easy choice for my project. In this project, there are several key objectives I aim to accomplish. Firstly, I must obtain 3 datasets containing Amazon reviews with 1 to 5 star ratings. Then, determine what data processing will need to be applied to them to ensure my models will output usable data. Once this has been established, the processed data will be passed to 5 selected machine learning models to be used as training and testing data, with each model's effectiveness established through the collection of evaluation metrics. In order to collect a suitable amount of data for my project, I sourced 3 different datasets from the online resource Kaggle. Dataset 1 contains earphone reviews with approximately 14,000 records, the smallest of the 3 datasets. It also contains the largest imbalance between classes, with the smallest class being 2 star representing only 15% of the largest class of 5 star. Because of these disadvantages, the machine learning models may struggle to achieve an accurate classification and will therefore produce a much less reliable result from my conclusions. This will, however, provide an opportunity to comment on the effect of poor quality datasets in regard to machine learning classification. Dataset 2 contains phone reviews with the largest number of records of the 3 datasets, with approximately 270,000 data points. This increase in size over the previous dataset should allow for much more accurate classification overall. However, dataset 2 still struggles with large imbalance, with its smallest class representing 30% of its largest class. This being accounted for in software, combined with a larger number of data points, should still reproduce reliable data to compare to the selected models. Dataset 3 contains food reviews and is clearly the highest quality dataset of the 3, with around 226,000 records, as well as its smallest class representing over 50% of its largest class. This dataset should produce the most reliable results and will be reflected in my conclusions when comparing the 5 machine learning models. In order to achieve my project's goals in the set time frame, I created a Gantt chart. This gave a quick visual indication of the current progress of the project and remaining time to complete the next objective. This, in combination with regular meetings with my supervisor, allowed me to complete my project in a timely manner. My software choices were key in my project's success, and this starts with my programming language of Python. This was an easy choice due to my familiarity with the language, as well as its common use for machine learning in many applications. To extend Python's functionality, I decided to utilize several packages made available to me through the Anaconda software. The most useful being scikit-learn, which gave me access to all of my selected machine learning models, as well as the tools to implement them with my chosen data sets and output all necessary evaluation metrics. The Natural Language Toolkit enabled me to process my 3 datasets into information usable for machine learning, without which all data outputted would be completely unsuitable for my project. All of the above tools were written in Python using the Jupyter Notebook application, which facilitated the creation of segmented and easy to modify code, something that is highly useful when dealing with machine learning applications. For the machine learning models, I selected 5 different algorithms, with each using different methods to achieve classification. I chose each with the intention to draw conclusions about the different methods and identify the strengths and weaknesses displayed by my testing. For example, the naive Bayes model utilizes a probabilistic model based on the Bayes theorem and is entirely different to the tree-based model of the decision trees model. The random forest model uses multiple decision tree models and therefore is expected to perform more accurately when compared to the single decision tree. Both linear support vector classifier and logistic regression models use data points plotted on graphs to achieve classification, with different mathematical lines of best fit to separate data points into classes. These models were trained and tested on the same 3 datasets, and their outputs evaluated into metrics that I can use to draw my conclusions. The evaluation metrics are essential for this project, as they provide the data which will enable me to directly compare the performance of the machine learning models against each other. I have chosen to utilize both numerical metrics as well as a form of visual representation for these metrics to allow for easy identification of strengths and weaknesses between each of the models. This data will also allow for the comparison of the 3 different datasets and how they will affect the classification effectiveness of each models. Accuracy is the most basic of metrics, with it simply being the percentage of correct classifications made. While this seems like a very effective method of comparing a model's success to another, more metrics will need to be considered to form accurate conclusions. Precision and recall metrics both provide ratios between the classifications of the model. Precision is the ratio between the number of collect classifications against the number of all classifications, whereas recall is the ratio between collect classifications against the actual number of elements in that class. While both of these metrics are useful, they can be biased when considered on their own. Therefore, F1 score is used to balance precision against recall to give the most reliable numerical results of these metrics. F1 score will be used as one of the strongest methods of comparison between machine learning models in my project. The final evaluation metric is the confusion matrix, which maps the actual results of classifications against what the machine learning model guessed into a table. This is incredibly powerful for multi-class classification problems and can be combined with a heat map to help an observer visualize the spread of data in the table. When a model has made an accurate classification of a dataset, a clear diagonal line will be visible across the table and can be seen with a yellow color in my project's empirical results. I believe that by considering these evaluation metrics, I will be able to create strong conclusions for my project, backed up with empirical data collected. Some of the strongest data I have collected from this project is the clear efficiency of the random forest model over other selected models. This was established through the collection of data and observation of clear trends indicating its effectiveness for my project's application. This is visibly demonstrated in both the confusion matrices and F1 score produced by the random forest results. This may be due to the fact that a single decision tree model was already one of the strongest models in the group, and with random forest utilizing multiple instances of the decision tree algorithm, it only increases its strength in classification applications. The other clearest conclusions to be drawn from this project is the effect that poor quality data has on certain models' performance, and this will have to be considered when drawing my conclusions in this project. This is clearly shown by the drop in performance of the top 2 models when compared to the other 2 more substantial datasets. It is interesting to note that both linear SVC and logistic regression models showed increased performance compared to the other models in this lower quality dataset. This may indicate that these models are more adept at classifying smaller datasets than the other models. To conclude this project, I have successfully implemented a usable natural language processing system which has allowed my program to generate data for the testing of machine learning models. The data generated has enabled me to create conclusions of the effectiveness of each model and which would be the most suitable for use in a similar scenario. The results have demonstrated that the random forest classifier was the most effective out of the tested samples, but only while the input data was of sufficient size. It's clear that this model suffers more than others when a smaller sample is used. On the opposite side, the naive Bayes model failed to create as accurate classifications as the rest of the tested models, marking it as least desirable for use in this application. In reflection, I am satisfied with my choices of software to complete this project, as well as feeling that my knowledge within this subject has been greatly improved. It is clear to me that while I am able to create sufficient data for my project, the task of multi-class classification of natural language is incredibly complex. This is exacerbated by my choice of 1 to 5-star reviews for my datasets, which is an example of ordinal data that has no clearly defined boundaries between the 5 classes. If I were to improve this project, I believe that more time would need to be spent on complex data processing, as well as experimenting with more formal types of natural language with ordinal classes, something that I believe would create more defined classifications from the selected models. In terms of continuing this work in the future, I would love the opportunity to apply more complex classification algorithms and experiment with cutting-edge machine learning software applications that are being developed for future AI implementations. Thank you for your attention during my presentation.